We're ready to start 3G on the bottom of page 1 of the practice test. This one takes a little bit of work, so let's go ahead and write attach page there and go over to another page to work on this. I've already taken the liberty to write it down, so go ahead and write it down if you haven't already done so. So this one's quite a bit more difficult than F, because instead of having monomials, one term in the denominator, we have two terms, one with one, and then three with two. So anytime you have two terms, first you have to look for factoring. So x plus 2y, nothing common, no exponents, so that one doesn't factor. Now this one has an exponent, so I should have my antenna up. And look at that, x is common. Same thing here. So on the next step, we'll go ahead and factor out that x, because we can't tell what the LCD is until we get everything factored. So the 3 over x plus 2y is going to stay the same. And I see that nasty little negative, so I'm going to take care of it right now so I don't forget it. So add the opposite, and we can now factor that denominator. So the numerator is going to stay negative 2y for now, and the denominator we said has an x common. The exponent tells you to look for GCF, or squares or cubes, and GCF it is. So when we divide each of these by x, we now get x parentheses, when x goes out of there, we'd have plus 2y. And then over, we have the same denominator, so it's going to factor the same way as that last one. So we have 3y, take an x out, divide each by x, and we get x plus 2y. Just like on the last one. And then last but not least, this one doesn't factor, so leave it as 5 over x. Now we are officially ready to declare the LCD. So remember the rule from 5.3, write everything you see without repeating. There aren't any exponents, so we know the LCD won't have any exponents, because the rule is write everything you see with the highest exponent. But since we don't see exponents, so I see an x, an x, and an x. All of them have power of 1, so my LCD is x to the power of 1. And I see an x plus 2y to the first, an x plus 2y to the first, an x plus 2y to the first. So the highest power I see on that is to the first. So write everything you see. I see an x 3 times, and I see an x plus 2y 3 times. Remember, I don't add the exponents. I just write the highest power I see. So now our goal is get rid of the fractions. So we get rid of the fractions by multiplying every single term by the LCD. And remember, when it's a fraction, you put it in the numerator so that you'll know to cancel on the next step. So x, x plus 2y. I'm going to extend the fraction bars just a little bit. And so this is going to be x, x plus 2y, oops, x plus 2y, x plus 2y. And then it's going to be cancel mania, because that's the whole reason we do this, is so that we can get the denominators to cancel. So x plus 2y divided by x plus 2y is 1. So guess what I have left? Something sweet and simple, 3x. That's it from that first term. Then I have my plus sign. I don't think I want to write the plus, because plus or minus is minus, so we'll write minus on the next step. Woo, look at this one. X plus 2y divided by x plus 2y, 1. x divided by x, 1. And the reason we can cancel those is because this is all multiplication now. I can't cancel things added and subtracted, but I can cancel things that are multiplied. And so what do I have left? Minus 2y. Yes, you could write plus negative 2y, but we try to shy away from double signs, so plus a negative is really just minus. But look at that. All that ugliness turned into this. These are so fun. You take such ugliness and make beauty. So x divided by x is 1. X plus 2y divided by x plus 2y is 1. So we simply have 3y there. So look how simple this problem is ending up being. Only hard part is factoring and finding the LCD. After that, it's just cancel, cancel, cancel. So x divided by x is 1. Oh, here's our first bit of work. So we're going to have 5 parentheses x plus 2y. So it looks like the only work we need to do is distribute and combine like terms. And then look for factoring if there is any. So in the numerator, there's definitely no factoring, nothing common, no exponents. So let's go ahead and do this one underneath. 3y plus 5x plus 10y. So this one turns into 5x first because we want everything alphabetical. 3y plus 10y is plus 13y. So 3x minus 2y. Here we distributed and we got 5x plus 10y, and then we put our terms in alphabetical order. So this one first, and then these two turned into 13y. Does anything factor? Anything common? No. Any exponents? No. So it can't be squares or cubes. So guess what? All that ugliness just simplified to this. Piece of cake. Love it. There we go. That's the end of 3G. So first page done. Let's go ahead and go to the second page. Again, we'll do a couple on separate paper. I think once we get to the word problems, we'll be able to write them on because I left plenty of room for that. But on this one, I looked over it earlier, and I think we'll do these two on this paper and then these two on a separate. Okay, let's look at 4a. So solving equations is almost identical to what we just did. You look at all the fractions, you write the LCD. Then you multiply every term by the LCD, and voila, the fractions disappear. The only thing we have to do at the beginning, because there's x's in all these denominators, is we have to write our restriction box. I did put one on the test that an answer comes from the restriction box, and you have to be sure and cross the answer out. So make sure anytime you see solve and there are x's in the denominator, you have to decide what x cannot be. Anything that makes the denominator 0 has to be thrown out. So this one, the only thing that makes x 0 is 0. So put it in a big box. Make sure it's easy to see, so when you're done, you won't miss it. If you get 0 for an answer, you have to throw it out. Okay, step 2. Step 2, find the LCD. I see an x and I see a 2 and I see an x. The highest exponent I see is 1, so my LCD is 2x. Remember, I never repeat. And I never add exponents. I take the highest power I see, and the highest power on x is 1. Highest power on 2 is 1. So now we write the fractions nice and big so that we are ready for the canceling. And I did put one nice and easy like this on the test. I think it has 4 fractions instead of 3, but same kind of problem. So just like we did on the last problems, the complex fractions, in the numerator of every single term, we write the LCD so that we can cancel, and on the next step, the fractions disappear. So watch how sweet this is. X divided by x Look at that, fraction's gone. So all I have left is 8. 4 times 2. On the second one, the 2's cancel. Sweet. So all I have left is plus 1 times 1 is 1x. And most students that miss these, miss them because of neatness. That's why I say write it big so it's really easy to see what's left. 4 times 2 is 8. 1 times x is 1x. Here the x's cancel, and so I'm left with 10. Now you guys can hardly beat that for easy. One-step problem left after you get rid of the fractions. I solve for x, so we learned how to solve for x. You take everything that doesn't have an x over to the other side, and that leaves us with 1x, which is just x, equals 2. Easiest problem ever. So multiply every term, fraction or no fraction, by the LCD. Cancel anything first, write what's left after the canceling, and then solve the resulting equation. So subtract 8, x is 2. Nice, huh? Then before we box it or put it in solutions, we look up here and make sure it's not in the restriction box. It is not. So that means 2 goes in our solution sets, and it is the solution. Okay, let's go ahead and take B over to the other page. So number 4B. Is 32 over x squared minus 25 equals, I think this is almost like the other one that I put on. I just put 2 from this section on just because they're kind of long problems. Okay, so we know we need to write a restriction box, but before we write a restriction box, we have to have all the denominators factored so that we know what the LCD is, because we can't figure out what the restrictions are until we have all the denominators factored, and we can't find the LCD until we have all the denominators factored. So on this first one, I hope you recognize the difference of squares. We've seen it a lot in this chapter, tons, 5 times on the first page alone. So this would be x plus 5, x minus 5, because we know whenever there's a negative, that's subtraction. That means they're different. So 1 plus, 1 minus, and we put the square roots in. Then we have equals. This denominator doesn't have a GCF, doesn't have exponents, so it doesn't factor. Now this one's going to take a little bit of work because first off, let's go ahead and add the opposite. Get rid of that little tricky negative sign. So easy to lose that. So this is, and I'm just doing this one term, negative 2. And remember how we don't want this written backwards ever? So what we need to do is turn it around so it is forwards. So negative x forwards, not forwards. How about descending order? I can't believe I'm using that word forwards. So we need to turn it around so that it's in the correct order, which is called descending order. We keep the sign that's in front of it with it. So negative x, positive 5. Well, then we learned that with that type of problem, we don't want a negative in front, so we have to take a negative out. Divide each term by negative 1, like we learned in chapter 4, and we get positive x minus 5. So do you all see that that simplifies? Double negative, positive. So this is really just 2 over x minus 5. So that's a plus sign. We got rid of the negative, so it's just